Hello, my name is Jolene Rhodes, and in this lesson we're going to talk about how to graph inequalities in two variables and the solution to systems of inequalities in two variables. So we're going to start with just the steps to graph a single inequality in two variables. So let's start with an example, and we'll list our steps as we go. So for example, what I would like to do is graph y is greater than 2/3 x minus 1. Now what we can see is that we do have an inequality sign, we do have a greater than sign in this problem. The steps though to graph an inequality in two variables, the first step is to basically ignore the inequality sign and graph the actual equation, the corresponding equation. So what we want to do is graph y equal to 2/3 x minus 1. So that's the first step to this problem. So what I'm going to do is let's get ourselves a coordinate system. And so what we're going to do is we just want to graph the line 2/3 x minus 1. Now what you should know is actually how to graph this line. We should know that it has a y-intercept at -0, -1. So I have this y-intercept at 0, -1, which we can see because this equation is in y equal to mx plus b form. We can also see that the slope of this equation is 2/3. So what we're going to do is go from that point, go up 2 and to the right 3. So I'm going to end up at the point 3, 1 over here. Now, before we connect the, and graph the line, before we connect those dots, the second thing we're going to do is we're going to look at the inequality sign. So we're going to look at the sign that we have. Now, if the sign has an equal sign, so we have either less than or equal to or greater than or equal to, what we're going to do is we're going to draw a solid line through those points. If we do not have an equal sign, what we're going to do is draw a dotted or a dashed line through those points. Now, if we look up at our problem, our inequality sign in this problem is strictly greater than. So what I want to do then is I am just going to draw a dashed line through my points. Now what you should notice is the line divides our coordinate system into two halves. There's a part above the line and there's a part below the line. One of those is where this is where y is greater than the 2/3 x minus 1. The other is where y is less than 2/3 x minus 1. We just need to determine which is which. My suggestion is to pick a test point. So what we're going to do is pick a test point, which can be any point not on the line. So any point at all not on the line. Because the points that are on the line is where it's equal. So what we're trying to decide is which side is actually greater than. Now, once we determine one side, we know what the other side is, because one side's greater than, the other side's less than, so all we really need to do is decide which side is which. What we're going to do is pick any point that's not on that line. A lot of students like to choose the point 0, 0, so I'll pick that one, and this is what I'm going to call our test point right here, which is the point at 0, 0. Now, the idea of a test point then is what we're going to do is take that test point and we're going to plug it into our inequality. So we're going to take our y greater than 2/3 x minus 1. We're going to put in our test point. So 0 for y, 0 for x. What we get is 0 is greater than -1. We look at that inequality. In this case, this inequality is true. If that's true, then that means that point is true. And if the point is true, that means that side of the line is the side that we actually want to shade. So our last step here is to shade the true side. Shade the true side, the side that makes our inequality true. Now, if we had gotten false, then the opposite side would be true. We would have shaded that side. So 0, 0 was true, so we're going to shade this side of that graph, and that particular example is done. Okay, let's move on and do an example of a system of linear inequalities. So what we want to do is have a system of linear inequalities. I'm going to use y is less than or equal to 2x minus 3, and y is greater than negative 1/2 x plus 2. Now, when we have a system, we are going to just graph each of them individually first and then find the solution to our system. So let's go ahead and start by using the first inequality. So the first thing we're going to do is graph the equation y equals 2x minus 3. So come over here. We're going to, again, want to graph that line. Now you can graph the line however you would like. You could plot points. You can, use the intercepts. You can do what I'm going to do, which is use the slope and the intercept because this is in slope-intercept form. So what I'm going to do then is I can see that this particular equation has a y-intercept at negative 3. So I'm going to put a point down here at negative 3. We have slope of 2. So from that point I'm going to go up 2 and over 1. I'm going to do it one more time just so I get a semi-straight line. Now, again, we look back at, second step is to look back at our inequality sign. We have less than or equal to. Since we have less than or equal to, that means what we're going to want is a solid line because we do have an equal sign as part of our inequality sign. So we're going to draw a solid line through those points. Now, the third step is we want to decide which side we're going to shade. So we're going to pick a test point. And again, it can be any point that's not on that line. So let's test the point, say 1, 1 this time maybe. Doesn't really matter as long as it's not on the line. So here's my test point at 1, 1. And what I want to do then, so here's the point I'm testing. And so let's go ahead and put that in our inequality. So we're going to get 1 is less than or equal to 2 times 1 minus 3, or 1 is less than or equal to negative 1. Okay, now 1 is not less than or equal to negative 1. That's false. So that means this point right here is false. If that point is false, then that entire side is false, which means the other side is true. So last step here is we are going to shade the true side. And again then, so that's not the side where we picked our test point, it's the other side. So I'm going to go ahead and shade down below that line. Now, we do the exact same thing, but with the other inequality, and we're going to put it on the same graph. So again, first step then is we're going to graph, so first step, let's do this, is we're going to graph y equal to negative 1/2 x plus 2. And again, so that has a y-intercept at 2. It has a slope of negative 1/2, so we're going to go down 1 and to the right 2. And I'll get this point right here at 2, 1. And then we're going to look at our inequality sign. In this case, we have a greater than sign. That means we're going to use a dotted line through those points. So we're going to have a dotted line through those points. And then we're going to use a test point. And again, it can be any point not on that line. I could use the point 1, 1 again, since I used it last time. We could use it again. If I put that in there, I get 1 is greater than negative 1/2 times 1 plus 2. That's 1 is greater than 3/2. And 1 is not greater than 3/2. So again, that's false. So this point again is false for that line also. So what we're going to do is shade the opposite side. So again, we're going to shade then as our last step. And we're going to shade the opposite side of where 1, 1 is. So we're going to shade up here. Now the final step to actually solving a system of inequalities is we actually want to shade the portion that is in common. So what we're looking for, the first time we shaded all of the points that solved our first inequality, then we shaded all the points that solved our second inequality, and what we're actually interested in with a system is the set of points that solve both inequalities. So what we're going to do is look back up here at our graph and say, okay, so where did we shade both times? And that's in this region of our graph right here. Let's be very clear that this is the region of the graph that we want, and that's where our actual solution is. So this is our solution to this particular problem, to this system of inequalities. Okay, let's look at another example where our system doesn't necessarily include two lines like our previous example. Let's look at y is greater than or equal to 2x squared minus 5, and y is less than say negative x squared plus 1. Okay, so what we have in this case is a system, again, of inequalities, but they're not linear this time. What we actually have are parabolas. So, but we're going to do the same exact steps to these. We're still going to graph the equation as if it has an equal sign. So the first thing we want to do is we're going to graph y equal to 2x squared minus 5. Now you should recall that that has an intercept at negative 5. So we have an intercept down here at 0, negative 5. And then it's a parabola. It's a concave up parabola, and you can do a couple of things, either plot points, or we can tell from this too that it's been stretched, the parabola's been stretched. So what we're going to do is actually go up to and over 1 on either side of this parabola to make it a slightly skinnier parabola than we normally have. Now if you would like to be a lot more precise, you can go ahead and plot more points. I'm going to just go ahead and sketch a parabola through that. If you want to be neater, you could put the x-intercepts on here too. I'm going to just go ahead and sketch that in, but before we sketch that in again, we still need to look at our inequality sign, and we have a greater than or equal to, so we are going to put solid graph through those points. So what I want to do is get a parabola in here. Okay, so I have a rough concave up parabola. Third thing, again, we do want to shade, and so we're going to need a test point. I'm going to choose 0, 0 as my test point. Again, you can pick anything that's not on this parabola. What I'm going to get is 0 is greater than or equal to negative 5 if I put it into my inequality, and 0 is greater than negative 5, so that's true. I don't know what I was writing. So that's a true. Let's start over. And as that's true, what we're going to do is shade the portion of the graph where 0, 0 is. Now 0, 0 is inside that parabola, so what we're going to do is we're going to kind of shade right in here. And then we're going to go ahead and do the same thing, but with our other parabola. So first thing we're going to do is we're going to graph y equal to negative x squared plus 1. That has an intercept at positive 1. It is a concave down parabola. It's standard width. So we're going to go 1 over and 1 down in both directions. I'm going to get a parabola. Whoops, before I do that, second thing we're going to do is look at our inequality. And what do we notice about that inequality? Notice that it is strictly less than. So what I'm going to do, I want a dotted parabola. So maybe I should have been a little more careful here. So this is going to be a dotted parabola in here, in both directions. Let's put our parabola in here. And last but not least, then we're going to again test a point. I'm going to test 0, 0 again. Since I used it the first time, I'm going to use it the second time. Keeps me straight. So I would get 0 is less than 1. 0 is less than 1, so we're going to shade the section where 0, 0 is on that parabola. That means I'm going to get this part right in here shaded. And again, what we want then is to look for what they have in common. So the part that is shaded both times, and the part that's shaded both times is actually this region that's right here in between our two parabolas. And that's the section that is the solution to this particular system of inequalities. Okay, I have one more example for you today, and we're going to use the system 2x plus y less than 0 and x squared plus y squared less than 2. Again, let me get a coordinate system here. First thing we want to do is we want to graph the line 2x plus y. So we're going to graph 2x plus y equal to 0. Again, you can solve that, you can graph that however you'd like. I'm going to rewrite this and solve it for y. So y is actually equal to negative 2x. If y is equal to negative 2x, we have an intercept at the origin, at 0, 0. We have a slope of negative 2. So we're going to go down 2 and over 1, or up 2 and to the left 1. We're going to then want to draw the graph. Again, looking back at our inequality sign, I have a less than sign, so this is going to be a dotted line we're going to put through those points. Want to pick a test point, and to me, I would always go back to your original to test, because that way if you've done some arithmetic mistake or forgotten your signs or whatever, you don't have to worry about any of that. Go back to the original. So if I go back to this original inequality right here, what I'm going to do is pick a test point. Now, we picked 0, 0 last time. Notice we cannot pick 0, 0 this time because it's on the actual line that we have, or it's on our dotted line. So I'm going to pick the point 1, 0, maybe right here. So this is going to be my test point. So I'm going to pick the point 1, 0. Now that means x is 1, y is 0, and the question is then, is this true? This is 2 is less than 0, which is false. And so we're going to shade the opposite side. So we're going to shade the true side, just like we did in all of our previous examples. We're going to shade that part of our coordinate system. Now, we've got one more inequality, so let's go ahead and sketch that one. We're graphing x squared plus y squared equal less than. Actually, let's make that instead of a 2, let's make that a 4. It'll make our lives a little easier. X squared plus y squared less than 4. Now, if you recognize this, or hopefully you recognize this equation, this is the equation of a circle. And so this is the equation of a circle. If we look at x squared plus y squared equal to 4, the standard equation of a circle is x squared plus y squared equal to r squared. So this right here is our radius squared. So this should be a circle with radius of 2. And so what I'm going to do is actually just go up here and draw a circle with radius 2. Now, circle radius 2 is going to have the point 2, 0, 0, 2, negative 2, 0, and 0, negative 2 on it. So it's going to go through those 4 points for sure. Before I sketch my circle in, let's look at our inequality. We do have a strictly less than sign, so I'm going to make that a dotted circle. So let's dot our circle in here. Okay, so we're going to get a circle that's right there. Third thing we want to shade. And what are we going to do? We're going to look for, again, you could use a test point. In this case, I can use 0, 0 if I want. If I put that into my inequality, I'm going to get 0 plus 0 is less than 4, which is definitely true. Or if you think about it, where is x squared plus y squared going to be less than 4? That's going to be inside your circle. So what we are going to do is shade inside our circle for that one. And last but not least, again, we want to shade the common region. And that common region that we shaded both times is this region that's right in here, in between our line and the outer edge of our circle. The edges of that are both dotted, so those aren't actually parts of our solutions, but they do give us the boundaries of our shaded region. And that concludes this lesson. Thank you very much.